Many of my European viewers have been asking me, what about roundabouts? Well, for the traffic system, we have added them. Here you can see a simple roundabout system, and the main thing is it supports it, and cars will wait till they can actually continue going forward. When there's no car in the way, it will go ahead. For example, these guys are waiting, and now it saw an opening that was big enough, and now it has gone ahead, and they will go ahead and just go accordingly. Just either take one of the random exits or just continue on and take another one later. And so they will now all continue going in a nice roundabout fashion. Also, I have gone ahead and fixed the little bug that I saw in the last video when I was editing it. I missed it when I was actually making it, but found it, fixed it. So we'll go over how to fix that little speeding up issue that we were handling last time and set up the roundabouts, which is actually surprisingly relatively simple because a lot of the stuff we already have done. And as you might imagine, they're a bit simpler to set up than the full-on intersections. Maybe we should really transition to roundabouts. It would make creating traffic systems a lot easier. For now, though, let's get started by fixing the one little bug that was happening last time. It's not the easiest thing to recreate, but it does happen. So occasionally, we will get a car that will just go and accelerate into the car in front of it way too much. So right now here is everything's fine. I can go ahead and try relaunching this one more time, see if we can get it to occur. Again, it's not an every time thing, which is why I missed it. Yeah, same thing here, did not get it, but here we go. Finally got it after several attempts. We're getting this mess. We need to fix this. So to fix it, we'll go into the car blueprint and open it up by pressing Control E, and then I'll open up the blueprint for the car. What we want to go and modify is in the drive forward. Over here, if I go ahead and zoom in, we can see here we're looking at the current speed times the get frame rate. This is all good for moving the actor forward. And when we have a spline, right, we're getting this again, current speed times the get frame rate with the relative speed multiplier if we need to. This is all good, but there's a fundamental problem with this. It's a small problem, but there is one. We're doing get frame rate. Get frame rate gets it every single time. But why is it getting it every single time? The actual timer that we're using right here is only gone once. So we should be using this time. Whatever we set here is the time that we should be using. So what could happen is the timer's going one rate, but because we're actually checking it every time we move, it can go higher or lower. And so the speed will effectively never be actually fully consistent. So all we need to do is record the speed we're going at, or rather the timer we're going at, and then just use that for our functions. Right before we do the set timer by function name, I'm just going to promote this get frame rate. I'll promote to a variable and I'll call it current frame rate. And then I will just go ahead and place it in here like so. So it will first store this frame rate and then we can go ahead and use that as our time. Everything else stays the same. But now here in the get future position and rotation along spline, we're no longer going to be using this get frame rate. We're going to be using the current frame rate. That's important. What is the current frame rate and get us the position relative to that? And then over here in the drive forward, right, we're using the get frame rate. We don't want to be using this get frame rate. We want to use the current frame rate. So we'll just grab that and swap this out. So current speed times the current frame rate times the actor forward vector. Here we still want to check it, the actual frame rate every single tick, basically. Every time it runs, check that we're not having a lag spike. That's what this is for. So here we want to have this current frame rate, as well as in here, current speed, current frame rate, and relative speed multiplier. There's a few more places where we're using the frame rate. So here under set current spline component, right, we're doing get frame rate. So again, we want to use the current frame rate here. Effectively, anything that is off of driving, we want to use the current frame rate. So over here, same thing here with the delay it by the current frame rate, not the get frame rate. The only places where you should be using this now get frame rate is wherever you're checking that it is not a lag spike and originally on the drive function to set it. And we go ahead and simulate, you should see that all the cars still move exactly as they did before. Well, a little bit better now. So that is good. There is one other thing I want to actually adjust here because that might be good, but I also want to slightly modify the car detection. If I go into the trace for car function and I set this for duration of 0.1 seconds, since that's the timer it's on, and I go ahead and simulate it, we can take a look that it is tracing ahead. This is all good, but watch what happens right there. As it came to the end of this, it stopped checking. It's not checking ahead, and then it pops forward. Then again, it will get to the end of this, But I want this car to know what's going on a little bit further ahead. I don't want it to just stop at the end of that spline. I want to go past it. That way, if there's a car there, I want to know about it and brake accordingly. So in the trace for car section here, up here is when we're getting the location along the spline. We want to go past it, but only when our actual distance along spline is bigger than the actual distance the spline is. So let's first find out the distance along the last spline point. So we'll drag out from the current fall spline, and we can do get distance along spline at spline point. So basically we can use the last spline point to find out what the distance of this entire thing is. So from the current fall spline, get number of spline points. And as you recall from the previous ones, this is the total number. So it starts at 1. We need an index, so it starts at 0. So we need to go ahead and subtract 1 from it. And that is the actual index of the last point. So now we know the distance of this spline. I'll go ahead and just kind of move this over because we need a little bit more room. We can now check that this distance that we're calculating that we want to go to, is that distance greater than the get distance along spline at the last point? Because if it is greater than, that means that we are past the spline. What the distance we're trying to calculate to is too far ahead. There's no spline there anymore. So what we can do now is find the rotation of the last spline point and basically move forward relative to that. So that way we kind of look forward a bit as we need to, basically along the forward vector. And then based off of that, we will select accordingly. So we'll use a select node and we'll plug in this Boolean here. So based on whether or not it is greater than the last point, because if it is not, then we're just doing the same thing as we were before. We're only changing what's happening now that it's true. So let's go ahead and get the rotation at the last spline point. Get rotation. We could do either one, honestly. You can do rotation at spline point since we're getting it here, or at distance along spline. I'll get it at the spline point so I can get it the exact spline point, just so there's no rounding errors or anything. And again, I'll put in the point index, same one as here. There we go. I cleaned it up a little bit, so hopefully it's a little bit easier for you guys to see what's going on. So we want to make sure that the rotation spline point is world. We're always working in world here. So we have the location we're trying to go to. We know the distance the whole thing is and the rotation at the last point. So now using the rotation at the last point, we just drag out and do get forward vector, which will convert the rotation to a forward vector. And now we need to move forward however much we've overshot. So we can take this calculation, right, how far we're trying to move, and subtract it from the max distance. So let's go ahead and kind of move these around. We'll say that the calculated distance minus, so subtract, the last spline point, that is the amount we're overshooting by. So now let's go ahead and take this forward vector and multiply it by this float, and then add it to the last position. So we just do an add here, and we'll add it to the place where we're going to go, which in this case will be the last point automatically. So we just use the same thing. We don't need to do a get location at the last spline point here. We're already overshooting it, and when you're overshooting it, the location will be the last one. So this addition then becomes true. And then this entire thing is what then gets set as the end trace location. So there we go. A little bit of cleanup again, so you guys can see it more. Our calculated distance minus the furthest distance along the spline, multiplied by the forward vector of the last point's rotation, and added to the last point's location. So that happens only when it is true. Otherwise, it just takes the location and distance along spline. So let's see what happens. So now, if we take a look, you can see it just went ahead and went right past it. And as the cars will go, you'll see that this, right, will continue on past it just like that. So now the cars will be actually checking even between the spline increments, which is basically what we want. The next thing I wanted to quickly fix is the fact that they're tracing all the way from back here from the car. They don't need to trace from the car. As you can see, we still have issues here. Look at that. Look at those issues. Yeah, those are very big issues. Look at that. Just this time around, all of them pretty much collapsed. Because while we did make it so we trace further, we didn't actually fix the problem. The problem is with the trace here. We're doing a distance check from the actual location, and then we're offsetting a little bit. Instead of doing it from the actual location, let's do it from the front of the car, so a bit forward from the car. So we'll use the get actor location. We'll also need the get actor forward vector. And instead of doing minus 300 here, I will just move the trace forward 300. So I'll do this multiplied by right click to float 300. So that way it multiplies all 3 axes by 300, and we'll add it to the actual location. So that is the actual new start of it. So just like this, we're now starting 300 ahead. And that also means that we shouldn't be doing this minus 300 here anymore. So we can get rid of that. That goes bye-bye. And the other thing I want to change is when the speed of the car ahead is faster, I'm going to remove this entire thing. I'm not going to tell it to do this at all. Only do this, basically accelerate, if there's no car ahead. Because the way I figured, one, it was causing a little bit of too many issues of it's always speeding up and slowing down, speeding up, slowing down. And that wasn't great. So this way, it will speed up when there's no car ahead. And if the car ahead is faster, it'll eventually be far enough ahead where it won't detect it. So it's a little bit of a double check there, effectively. So I'll go ahead and just get rid of this entire thing. And we can just use this branch as just from the false here. But in terms of this, right, it will still continue to try to do the stop car, all of this, even when it's matching the speed. So just like we did in the event graph for the deceleration, right, here it's as long as it's within 5, it will say true. And I want to do the same thing for the matching of the speed. If it's close enough, just set the speed as the car in front, and then just don't worry about it. So we want to do a little bit of calculations here after this cast to card base, and before we check that it is less than. So I'll go ahead and just take all of this and scooch it to the right. And I want to know if the current speed of the car that we just traced to minus the current speed of our car, is that less than 5? Right? At that point, we're effectively matched speed. But I also want to only do this when the deceleration distance is actually that we're meant to be stopping. So the deceleration distance, as long as we're slowing down, so it's getting smaller, 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 if it is within 50 and the speed is within 5, just match it. So right click, get current deceleration distance. Is that one less than 50? So we are slowing down. And if the speed is within 5, we'll do an and Boolean here. That means we just basically don't need to do any of the stuff. So let's do a branch here, and we'll say, okay, from here, go ahead and check this. If it is not within this parameter, we're doing the braking as we were before, because we still need to do a little more. And just real quick, I just changed the kind of the organization of this, if you're looking at it. But if this is true, then I want to set our current speed. So from true, we'll do set current speed to be the current speed of the car ahead. So we'll just go ahead and grab that and pull that through. Now, we could add a safety net here, because in the scenario where the car ahead of it just runs out in front of it and they have a higher speed than our max speed, we can just make sure that it is not like over our max speed. So for that, we just use a min float first. So by using a min float between the current speed of the car that we just checked in front of us and the get original max speed, so that's the full max speed that we can go. Whatever one is smaller here, go ahead and use that as the new current speed. So that way, if our max speed, let's say, is 100 miles per hour and the car ahead of it jumped out ahead and is 120 miles per hour, or I guess within here will be 103 miles per hour, we'll still say keep it at 100. So all it's going to do now is just set this to be that speed and we're good. So now we're no longer constantly doing the stop car or the start acceleration, no matter what happens here. We have a scenario where it does neither. And after we set the current speed here, let's go ahead and set the current deceleration distance to be 0. We've arrived. The distance is 0, which means if we were running the stop car, it would stop running the stop car and everything should be good. So when we start to accelerate, I want to set the current deceleration distance to be, again, a very high number. So we'll go ahead and set it as such. So basically, when it starts to accelerate, reset this back. So once it goes here to acceleration, right, it doesn't keep the tiny number of the current one. So this will not immediately just stop the car. And now we take a look. It should now be completely fine with no issues whatsoever. Now I say that and I am nervously looking at this because, I said that before and I've said it again. And so that means that I will now spot a problem that I previously missed. I wish I did it. I wish I could say it's 100% flawless. There's no mistakes. And from my observation right now, still running in the background as I'm speaking, and I've done tests before, there are no issues. I am still hesitant to say it's actually fixed. because it's hard for me to believe that it's maybe finally fixed. But even now, as it's been running for a while, you can see the cars are still going. There's no intersections of the cars anywhere. They're still continuing on. You can see here they're slowing down even on the curves, which is great. And yeah, there's no like intersecting cars that are going through each other anymore. So I think it is now fully done. As you can see here, it stopped just fine. So yeah, I think we're actually fixed. Yay! I say that and I immediately spot this. I spot that immediately, but it's a curve. Okay, a curve is slightly different. A curve works slightly differently. The distance there is slightly different. I'm going to excuse that one on a curve. Okay, I'm excusing that one. Everything else is fine. I don't see any other issues. I'm excusing the curve. So with that now working and good, let's get to the actual thing that you guys wanted to see, the roundabouts. So here in a new kind of layout, I just have my regular road splines, which are these green ones as before, and a few of the intersection splines, which are the blue ones, and those are the ones that are turning right. So every single one of these is just a regular road one, except these guys. The ones that get onto the roundabout are the intersection splines that we had. Because if you recall, we have the road spline and the road spline intersection. We're using these, right? They're blue compared to the regular green ones. I've gone and added in the cars for the testing, and you'll see that this one will go off or straight as before, and these guys stop immediately at the intersection ones, because by default, these are all off. They say stop. That's their default state. So while a car can get off the roundabout, right now nothing can get on. The way we're going to do this is we're going to give it a little bit of a zone. Check the cars in this area. If there are no cars in this area, unlock that intersection spline so cars continue going. If there is a car in this area, then say, hey, the way is blocked is effectively a red light versus green light based on whether or not there's a car or multiple cars in an area. And the same way the intersection then tells it to, hey, tell that car to go, we will do the same thing. So to do that, let's make a new actor. Right-click, blueprint class of a type actor. I'll call this BP Roundabout Entrance. I'll go ahead and open it up. And here, I'm going to add in a box collision. Depending on your setup, maybe a capsule collision would be better, maybe a sphere one. I find the box is good enough for what I'm doing, so that's what I'm going with. I'll just adjust some things on this box collision, starting with the box extent. I'm going to change it to be 500 by 500 by 100, so it'll be considerably bigger by default. We can scale this in the world as needed, but so it starts at a bit bigger. And we also need to go down under the collision here. So collision presets, we want to do custom. And instead of being an object type world dynamic, it is a traffic intersection. So we'll go ahead and select traffic intersection, select ignore and everything. And I only wanted to overlap vehicles. That's the only thing. And that's all we need for this box collision. We're going to need a few variables though. We're going to need to specify which one of these road spline intersections is the one that it is controlling. I'm currently setting it up to only control one per because of the way I have it set up here, right? There's no reason for cars all the way back here to affect this one. And this one only really cares about this area here. But basically all we need to do is add a variable of that road spline type. I'll call the first variable road spline intersection, and this is going to be of a type of BP road spline intersection object reference. And I want to make sure that it is exposed, so I'll hit the eye icon here. And then I also want to keep track of all the cars inside. So we'll add a new variable. I'll call it something like cars in the way, because these are all the cars that are currently blocking the way forward. And this is going to be of our type BP car base object reference, but it needs to be an array, so I'll right click and convert to an array. So now we have the spline intersection it is controlling, and we can store all the cars that are actually inside of this volume. So now, in the event graph, let's set things up. We're not going to need the actor begin overlap or event tick here. The first thing is, on begin play, take the road spline intersection and set stop at intersection. Go ahead and say that at the very beginning, hey, go ahead and go. It's a green light now. Everyone has the right of way, right? Because there's no cars. By default, it's green compared to a regular traffic light that has multiple lanes that's controlling a regular intersection for a cross intersection. That by default is a red light. So already we can already test this out. All we need to do is take this roundabout entrance, drag it out here, and I can angle it to something like this. That way I get less of this area and more of this area. So I can say, hey, if there's a car in here, then in the detail panel, we can just go click pick actor from scene and click on this road that we're actually telling it to control. So we're going to click on it. You'll see it gets populated here. And now this one is controlling here. So if we just do a test just with this one, and I go ahead and simulate, you will see that all of the other ones will stop, but this one will start going forward because thinks it's a green light. So all we need to do is just copy this around and paste this inside of all of the other locations. Again, we'll do the same thing here, move it into position, but you want to make sure you re-pick the actor here, pick this new one for each one of the 4 ways. And when you have all 4 in place and you simulate, you should see that every single one of these cars will now just automatically start getting onto this roundabout, just like so. So let's tell it to wait when there's a car in here. That is relatively simply. All we need to do is right-click on this box, add event, on component begin overlap, and right-click on it again and add event on component end overlap. In both scenarios, let's make sure that's the car. So from other actor, we'll do a cast to BP car base. And this is from both of them using the other actor. On the begin overlap, if it is successful here, then go ahead and add it to the cars in the way. So we'll just do add. And just to be safe, I'm going to do add unique in case somehow it calls it multiple times. Maybe there's a little bit of a hitch and it somehow gets just out, just back in. I want to do it add unique to be safe. And if there is now something in here, go ahead and take the road supply intersection and the stop at intersection and say, hey, stop at the intersection. There are cars here. So as soon as one car goes in, it gets recorded and it closes it down. When it exits, we take this cars in the way and we do a remove item. So go ahead and remove this car from the array. And then we want to know, hey, are there any cars left? So from the cars in the way, we can say is empty, and we can know, hey, are there any other cars in the way that we're waiting for? And based on this, we'll use a simple branch here with the is empty as the condition. If it is actually empty and we're not waiting any more cars, well, let's start with saying stop at intersection is now going to be false. Go ahead and make it a green light effect. But when you do that, we need to do the same thing we were doing before, which is basically telling the car that is there to go. If you recall on the actual traffic intersection that we had before, right here, we're doing a sphere trace for objects for the vehicle, and then we're doing a cast here and telling it to drive. Well, guess what? We can copy this. Go ahead and copy this, come over here, paste it in, and then tell it to actually start and end. But in this scenario, we want to tell it to do that from the road supply intersection. So we'll grab this and then get actor location, and that's the location we're going to be using. In our case, this guy that is controlling the logic of it stopping is the original location. So as long as you don't move that somewhere else, which I don't see why you would, this should work without any issues. If you wanted to, you could do get box and you scroll down all the way to the bottom and get the box collision and then get world location of that box specifically, right? And then you can do it that way. But because its location should be the same, this is just a simpler solution. Now this will almost work, but you will find that the overlaps do not work just yet. The reason is this box collision, we told it to be a traffic intersection, but on our car, we're not actually checking for this. So all we need to do is go back to the car base, go to this box collision and turn on overlap under the collisions here for traffic intersection. Just do an overlap, do not block. Now let's go ahead and try out the intersections here, or rather the roundabout. I mean, it is an intersection, it's just a roundabout intersection. And you'll see that the cars will go on and this one will even wait for the car ahead. Now, is that ideal? Probably not, but we can go ahead if we wanted to and adjust this to, for example, only grab the beginning of this guy. So you can maybe adjust it to be something like this. So it only checks cars in this area. So it'll still grab a little bit of kind of down here, right? Maybe something like this. It's not going to be perfect, but it's going to work. And that's kind of the main thing. This entire system is not perfect, but it does work. I think that's a good representation of this entire system that I've been making, right? Cars get out of the way, make sure it has plenty of room, and then continues on. I mean, in theory, I wouldn't want every car to immediately go one after the other on a roundabout without checking. I don't personally have a lot of experience with roundabouts, but I feel like if you're about to enter a roundabout, you don't just go just because the car ahead of you went. You probably want to pause or stop and make sure the coast is clear. Doesn't mean everyone does it, but I have a feeling that's the normal thing to do. Or it's copium and I'm just telling myself that so I don't have to do a different system. Let me know in the comments below. But now we have roundabouts and regular T and cross intersections. In fact, the roundabout ones are just car sensing ones. They're not even really like intersections. So you can really make this any shape you want. It doesn't have to be a circle anymore. You just check if there's a car in the way, and if there is, it will stop it there, and if there isn't, it'll continue on. I think it could probably be used for on-ramps on freeways. That's for a different time. For now, though, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, link to the Discord and everything is down in the description below, as always. And if you're looking for something else to watch, I recommend this video right over here.